In the last video, we have discussed about the characteristics of equilibrium constant. Here it is another case of that characteristics of equilibrium constant, which is the temperature factor. So when you see two equilibrium constants K2 and K1 for any reaction, and you have two temperatures. So for K2, it is happening at T2 temperature and it is happening at T1 temperature. There is an equation for it, that is log base 10 K2 upon K1. This equals to delta H, which is the enthalpy of reaction, that is enthalpy change of the reaction, and this is divided by 2.303 R and multiplied by T2 minus T1 upon T2 into T1. So what this equation implies, we will see here, that the case 1 I'm taking it as when enthalpy change is 0. Basically what happens is that this whole term becomes 0 as the enthalpy change is 0. So you can see that log base 10, any value when equals to 0, it becomes 1 basically. So K2 divided by 1 becomes 1, and here it is implying that K2 is equals to K1, and you can derivate that K, that equilibrium constant, is constant throughout, not changing into K2. So here no significance of the temperature is there. Next is case 2 for temperature factor, is that the delta H is negative. What happens when the delta H is negative? When you see the delta H is negative, this implies that delta H is less than 0 and the reaction is basically exothermic. We have studied in thermodynamics that exothermic reaction implies delta H is negative, and the log base 10 K2 by K1 is smaller than 0. This delta H negative condition implies. So you can say that K2 is smaller than K1, and if K2 is smaller than K1 then you can say that temperature increases, so equilibrium constant decreases. Next is case 3. So here I'm writing the case 3. So in case 3 I'm taking that delta H is positive, right? In the previous case we have seen that exothermic reaction, which is implying that temperature is higher, and we have derived that the K2 is less than K1. That means the next equilibrium constant decreases due to increase in temperature. Now what happens in this? This will be the opposite condition of this case 2 reaction. So here the delta H is greater than 0 and it is implying that it is endothermic. So what happens here, that the K2 increases with respect to the K1, and this implies that T2 is greater than T1, right? So temperature increment here implies that equilibrium constant also increases.